In this video, we're going to go through a few hints and similar problems to quiz 2. So the first kind of 2/3 of this quiz are dealing with this relationship between zeros, factors, their multiplicities, the end behavior, and how all that comes together with the graph and with these equations of the polynomial. So one type of question that we need to be familiar with is how many times is something a factor of a polynomial? To answer that question, you simply need to see how many times you can do that division with that problem. So here, if we're going to divide by this particular factor, it's x plus 3. So I need to do my division on -3. I do the division on the 0. And then go through the coefficients. We have 2, 11, 12, and -9. And then our synthetic division, bring down the 2, and then we multiply. We add down, we multiply. We add down, we multiply. If we get a remainder of 0, then it was a factor. So here, we know it's a factor at least once. Let's see what happens when we go again. And I can just go from my result. Here we have the 2, multiply, bring down, multiply. We get a 0 again. Are we going to get lucky for a third time? Bring down the 2, multiply. And that gives us -6. We have -7. So no, it's not a factor a third time, but it is at least a factor twice. So you can figure out how many times something is a factor by doing that repeated division. Now, we also can look at a function and we can answer a few questions about it. If we want to see if something is a factor, we do what we just did. We need to see if synthetic division produces a remainder of 0. So here I'll put -1 on the outside because that means that my 0 would have been -1. And I bring this down, multiply, bring it down, multiply, add down, multiply, and we see that yes, it is a factor. But how do I know if my function is going to cross at that particular value? Because see, here's the thing. I could cross with a concavity, or I could just touch. And it all depends on my multiplicity. So is this -1 a multiplicity of 1, or is it maybe a higher multiplicity? So let's see what its multiplicity is. Let's multiply again. Bring down the 1, multiply, add down, multiply, and we see that it is a multiplicity at least of 2. Let's see if it's 3. We do one more synthetic division. Bring down the 1, multiply. No, it's not 3 times, but it is twice. So what happens to the polynomial when it touches, has a multiplicity of 2? It does not cross, it'll just touch, it'll stay tangent. And then if you want to figure out if something is a root, then what you'll do is you'll do your synthetic division on that value. So I'm going to erase this, and we'll do synthetic division with -3. If we get a remainder of 0, then we found a root. 1, multiply, add down, multiply, add down, multiply, and no, this one was not a root. It would have been a root if we had gotten a remainder of 0, but in this case, we did not, so it is not a root. Oh, there's all my scratch work trying to get the right polynomial, sorry. So here we're trying to find a value of k so that we have found a factor. Same thing that we're working on here. You have a factor when you do the division and your remainder is 0. But what's different about this problem is we don't have all of the coefficients. So we're trying to actually figure out what the coefficient would be to force a remainder of 0. And so let's see how far we can go. We can bring down the 4, we can multiply, we can add down, we can multiply, but now we have k, so we can't add down, but we can work backwards. If I want a remainder of 0, then I needed to have a -6 under there because 6 plus -6 is 0. Well, then the question becomes what goes in this section so that when I multiplied by -3, I got 6. Well, that would be a 2. If I put a 2 there, I would multiply and get -6. So now I see that k plus 27 needs to give me 2. I'm basically forcing this to work out a certain way. And if k is negative 25, then the math would have all worked for us to have a remainder of 0. We can also use the same idea to try to find a fully factored form. Like, all of this is all coming together. There's a lot going on. And so it's, we definitely have to think about all the different concepts, and there's a lot here, but we can work through it. If we want to see a completely factored form, and we can't factor it ourselves, but we can do division to help us get to something that would be factorable. So I put my coefficients here and do x plus 2, which means I need negative 2 on the outside. So I have 3, then add down, multiply, add down. All right, and I got 0 like I should have. I don't know any other factors, but when I did this division, I got 3x squared plus 11x minus 4, which is quadratic. I can factor that. It might take a second because there is a leading coefficient, but it looks like if we do 3x minus 1 and x plus 4, that is going to work. And so my fully factored form, all I need to do is remember to put that x plus 2 from the original factor. That is a factor as well. And then we get our fully factored form. A few things to keep in mind when we are doing these polynomials is, what do we know about them? Well, we can look at the graph to tell if it's an even or an odd degree. Our odds, our cubic and our quintic, have opposite end behaviors, whereas our quartic and our quadratic have the same end behaviors. So that's one way we can look at it. We can look at how many turning points there are. There's at most n minus 1 turning points. So if you have 2 turning points, you have, it could be at most a cubic. If you had 3 turning points, it's at most quartic. And if you have 4 turning points, it's at most quintic. So that can also help you figure out what type of polynomial you have. The multiplicities you can find by looking at the graph and telling the behavior of the function at those zeros. If it just touches, if it's tangent, this is going to have a multiplicity of 2. If it crosses, but with that change in concavity, that's going to be a multiplicity of 3. If it just crosses, that's going to be a multiplicity of 1. And then here's another example of it touching, of it being tangent. That has a multiplicity of 2. So graphically, you can see 1, 2, and 3 based on the behavior at the graph. 1 and 3 crosses, 3 crosses with the change in concavity, and multiplicity of 2 just is tangent. And then our end behavior, we also can describe what's happening on the end. If you're going up, that would be as x approaches infinity, f of x approaches infinity. That's a right-hand behavior. If on the right hand it's going down, that would be as x approaches infinity, f of x approaches negative infinity. I should have done those as my right side, but it's okay. There's my right end behavior. And then my left end behavior, what's going on over here. On the left side, as x approaches negative infinity, f of x, if it's going up, f of x goes to infinity. But on the left side, if it's going down, as x approaches negative infinity, f of x would also approach negative infinity. So you can also figure out your end behavior from a graph. Now, solving polynomial inequalities does require a bit of work. If it's not already factored, you need to factor it, but then you'll make a number line with the zeros and just have them spaced out. It doesn't have to be to scale. So my zeros here would be -1, 3, and 5. From here, I need to figure out a test value. Let me split up my regions, and I'm going to do a test value of -2, a test value of 0, a test value of 4, and a test value of 6. Those are just values that all show up in those different intervals. Then I plug in that value into each of the factors. If I plug in -2 into my x plus 1 factor, that's always going to be positive because it's squared. When I plug in -2 into that next factor, that'll be negative. And then the last factor, it'll also be negative. But when I take a positive times a negative, overall, I'm positive. Now let's look at 0. Okay, 0 plus 1 squared, that's positive. 0 minus 3, that's negative. 0 minus 5, that's negative. But a positive and 2 negatives is overall positive as well. Let's plug in 4. 4 plus 1 squared is positive. 4 minus 3 is positive, but 4 minus 5 is negative. Whenever you have an odd number of negatives multiplied together, you'll have a negative result. Okay, even negatives will cancel each other out, but if you have an odd negative, you'll have 1 left over. And then finally, plug in 6. So we have 6 plus 1, that's positive. 6 minus 3 is positive. 6 minus 5 is positive. All positive stays positive. The last thing we need to do is look at what type of polynomial we are looking at. And here we are trying to do greater than or equal to 0. So it's going to be all of my positives as well as all of my zeros. So I need to make sure to include all of my zeros. And so sometimes you have to do this by identifying a 0 all by itself if it's not included in any of your intervals. But in this case, we're fine. Everything will be included. We have negative infinity, and I can actually go all the way to 3 since it's greater than or equal to. Negative 1 is fine. It's equal to there, so I can include it. If I could not have this, the equal to, I would have had to skip my 0. But that was not the case here. So I can include both of these positive, then union with the last section, 5 to infinity, and that covers everything where it's greater than or equal to 0. Now finding the equation of the line, remember that the inside is your x, your outside is the y. And we can go back to what we did, make those 2's. What we did really in algebra, geometry, our equation of the line, you needed the slope, so it's y2 minus y1 over x2 minus x1. 5 minus negative 3 is 8. 3 minus negative 2 is 5. So we have a slope of 8/5. And I like to use the point slope formula. It's just a little bit easier to work with. So pick either point. So I'm going to do y. I'm going to pick the second one just because that's the one I want to do. Fewer negatives. So I plug in my y1 and my x1, and then I distribute, and I'll be done. Y minus 5 equals 8/5 x minus 24/5. Now I do need to add 5 to both sides, which adding 5 is the same thing as adding 25 over 5. And so my final answer ends up being 8/5 x plus 1/5 when I add those fractions together. We also were finding the vertex. There's 2 ways of finding the vertex. One is completing the square. The other is just using the formula, negative b over 2a. So in this case, our b is negative 6. So we're doing a negative 6 over 2 times 3. So we have 6 over 6. So the x-coordinate of the vertex is 1. To find the y value, I need to evaluate the function at 1, or at whatever x value that I get. So 3 times 1 squared minus 6 times 1 plus 1. We're looking at 3 minus 6 plus 1, negative 2, which tells me my vertex is at 1, negative 2. So we're just using that vertex form. Whoops. This needs to be 20. We can also look at these application problems. And if we have a profit that depends on the amount spent on advertising, with this model, where P is the profit, X is the amount spent on advertising, if we want to try to maximize or minimize something, we're really just looking for the vertex. The max or the min is always your vertex. So in this case, if I want to maximize, I need to find my vertex. So it'll be negative b. In this case, my b is here at the 20. My a is the negative 0.5. So 2 times negative 0.5. So it looks like my x needs to be 20 here. And when I have an x value of 20, that is telling me how much I should spend on advertising. And that's all that this question was asking for. It wasn't asking for what would be the maximum profit. It said how much should we spend on advertising. I just need the x. Had I needed to know how much the maximum profit was, then I'd have to plug that in, but that's not part of the question, so we can move on. Writing in standard form, you can always get the vertex and then force it into standard form, but I find it easier to complete the square here. So when I complete the square, I'm figuring out what goes into this little box so that I get a perfect square. I get the perfect square by taking half of this middle value and squaring it. So half of 8 is 4, squared is 16. But if I add 16, I also need to subtract 16. Then I can factor, and it'll always be one of these perfect square trinomials. That's kind of what we're doing here. And there is my standard form. So that's why I like using the vertex or the completing the square, because it's less work in my opinion. But if you would rather use the vertex form, you could have done that. You would have gotten the vertex as 4, 5, and then you just put it in that vertex form where A is the same as the A in the problem, which in this case was just a 1. And then we also do these types of modeling problems where you have a path of a ball or the path of a rocket or something that is affected by gravity. And there's really 2 things that you're interested in. One of them is what's happening at the top, and one of them is what's happening at the bottom. So the top is going to give you the distance, that's your x, it's the distance from how far, and then the height. And I got that because I was told that f of x is the height and x is the distance. So you're told that in the problem. So if my question is how high does the football go, I'm looking for the height at the vertex, so the y value. I can find that by first getting the x value of the vertex, which is -9/5 over 2, -16 over 2025. And I do have some ugly decimals here, so I am going to be careful. Or if they're nice enough decimals or fractions, if you want to turn them to decimals, that's fine. That denominator, though, is not so friendly. So maybe using the decimal was not the right choice here. Just be careful with the way you put these into your calculator. Do -9 divided by 5 divided by parentheses 2, and then another parentheses, -16 over 2025. Wrote too many zeros. And that's just, if we don't put all of those parentheses in, the calculator gets real confused. So -9/5 divided by 2 times -16 divided by 2025 with all of those parentheses. And it looks like my x is 113.9. That is the distance here based on the equation. And then I need to find f of that value in order to get the height. And so I'm just going to plug that value into the function. So I'm plugging, x is 113.9 and figuring out what this is going to equal. So when I do that, I get 104 feet. So that is the answer to this first part of the question. But if I was asking instead how far away from the kicker, then that's the x value. X is that distance. So that would be the 100, about 14 feet. So it's kind of a quick overview of the different types of problems from this quiz. So I didn't want to do the exact problems, and I just wanted to give you some hints to get kind of your memory going, because I do want you to have an extra attempt at this quiz. So if you take the extra attempt and it's still not working out very well, then we'll take a look and see specifically what's giving you trouble. But hopefully this was enough just to kind of get you on the right track. But of course, if you still are not certain and it's still not going well, we'll spend some time and go a little bit deeper in this.